Hello everyone and welcome to this video on histograms. And you'll notice that I've labeled this histograms 1 because there will be two different videos going over this topic and different types of questions that can be asked on this section. So let's have a look first at the key information, what histograms are about. So histograms are used to display continuous data. And as we've discussed in a previous video, continuous data is basically data that can be any value, any number. And we tend to display continuous data always in an interval. So you might have x is greater or equal to 10 but less or equal to 25. And if x is the weight, then x can be, let's say, the weight of cats in a cattery, just to make up a random example. Then x can be any value. So the cat could be 11.25 kilograms. It can take any value between the upper and the lower boundary. And notice that it says greater than 10. So the lower boundary is 10. It does not include 10. And it's less than or equal to 25. So it does include 25 in that interval. Okay, so we use histograms to display continuous data. The second point is that histograms, some people say they're like bar charts. The only connection really is that they have bars, but for the rest there's no connection. So I made a pointer to say that unlike in bar charts, there are no gaps in between the bars. And the reason is that the data is continuous. So if I'm measuring weight on the vertical axis, sorry, the horizontal axis here, then if this is 0 to 10, and that's 10 to 25, and the next one, let's say, is 25 to 28, and then 28 to 40, etc., it's continuous. This keeps on going. So the bars that I draw will be connected in this way. And you'll notice they could have, or they will have, most likely unequal widths. And the reason, that's the next point, for unequal widths is that the data is usually grouped into unequal class intervals. And remember, interval, we call this the class interval. This bit is really important. The area of the bar, so the area of this bar, which means this distance here multiplied by this distance gives me the area, is proportional to the frequency of the interval. Now in GCSEs and IGCSE, the scale factor is always 1. So we're just going to say that the area is equal to the frequency. The area is equal to the frequency. So if you can work out the area of this bar, then you know what the total frequency of cat weights will be between 0 and 10. I'll know how many cats I weighed. So let's say the area here, let's say that, okay, that's a distance of 10, and let's say that's a height of 2, then the answer is going to be 20, which means I had a total number of 20 cats that weighed between 0 and 10 kilograms. Okay, more on that later. The bars in a histogram are unequal in width, and that's because our class intervals, as we said there, are unequal widths. This is the next really important bit. Before we can draw a histogram, we need to calculate the frequency density of each bar. Now the frequency density is what goes on the y-axis. Okay, so this axis is always going to be labeled frequency density. And on my horizontal axis, I will always have whatever it is I'm collecting information about. So weight or time, etc. And it will always be continuous data. And here is the formula for calculating the frequency density. And in a way, you will know that already because if I have my class width here, so the width of the bar, the width multiplied by the frequency density, I get the area of the bar. And remember, we said the area is just the total frequency, which means if I rearrange that, that frequency density is frequency divided by the class width, CW. So the class width, and class width is the width of the interval. So for example, here the class width is 15. But don't worry, we're going to work through two examples, and after we've done that, this will all hopefully make sense to you. Okay, so here's my first example. This table below shows the results of a maths test for 35 Year 10 students. Use this information to draw a histogram. We know now that on the vertical axis I've got the frequency density. I have my score in percentage on the horizontal axis. I need to, in order to draw my different bars, frequency 3, 5, 12, 10, 3, 2, these bars, I need the frequency, and I'm just going to write that FREQ, density. I need the frequency density. So you're going to set up an additional column here. Okay, I'm going to set that up. And remember, we said the frequency density is the frequency divided by the width of each interval. So I always just squeeze in a column there. You can write out this formula. Frequency density is equal to frequency divided by width, just to remember that. Okay, so now that we've got that sorted, let's go and calculate the width. Well, 40x lies between 40 and 50, that's a width of 10. 50 to 60, width of 10. 60 to 75, a width of 15. 75 to 80 is 5. 80 to 85 is 5. 85 to 100 is 15. Okay, now I'm good to go. Frequency divided by width. 3 divided by 10. 3 divided by 10, which of course gives me 0.3. 5 divided by 10, 0.5. 12 divided by 15 is going to be 0.8. 10 divided by 5 is 2. 3 divided by 5 is 0.6. And 2 divided by 15 is 0.13 recurring. Okay. Right. Now I'm good to go. So, frequency density, I need to check how far this goes up, as in what's the highest value. And I notice the highest value of my frequency density is 2, which means on the vertical axis, I need to go up to 2 there. And I know I'm going to have 0.5, 0.8, etc. So I'm just going to make sure that I label my axes correctly. And that's going to be 1, 2, 3, 4, 5, 6, 7, 8. Up to there, I'm going to do 0.5, 1.0, 1.5, 2.0, 2.5. Of course, you can use a different scale if you wanted to. Okay, so let's go and draw the first bar. So I notice here that 40 to 50, that's going to be in between there, 40 to 50, and it goes up to 0.3. So I'm going to zoom in. That goes up to 0.3. So 40 to 50, that is going to be my first bar, up to 0.3. The next bar, 50 to 60, is going up to 0.5. So I'm going to draw 50 to 60, and it has to go up all the way to 0.5. That's my next bar. There we go. Next bar is 60 to 75, so I'm going to go all the way from 60. Can make my little marks there, 60 to 75, and it goes up to 0.8. So I just look, 0.8 is there, so I'm very careful not to make a mistake. 0.8, there we go. That there is my third bar. Okay, on to the next one. 75 to 80, 75 to 80. There, I'll make my little mark, and it goes up all the way to 2 up there. So I just shade it in. Next one, 80 to 85. There we go. It goes up all the way to 0.6, which is there. And then the next one, 85 to 100, goes up to 0.13. So I know that this is 0.1, so I'm just going to make it slightly bigger. And I would recommend using a ruler in the exam when you draw your horizontal lines. Use a ruler, especially for the broader bars. And there we go. We can go and work this out just to double check if you wanted to. If I go and multiply 10 by 0.3, 10 times 0.3 is equal to 3. And when I compare that to the frequency, I notice that is correct. I have a total frequency of 3. Here in the next one, I've got 10 again, 10 and a height of 0.5. 10 times 0.5 gives me 5, and that is correct because my total frequency there is 5. Okay, so, and you can continue and check all of them. There we go. I hope that was useful. We're going to have a look at a second example, but I just want you to note, generally after drawing your histogram, you will be asked to solve some problems based on what you've drawn, or you will be given part of a histogram and part of the table, and you'll have to use both of those in order to work out the missing parts in the table, missing bars in the histogram. But we're going to have a look at that in the second video. Let's first do one more example to make sure we get a hang of this. In this example, it says the table below gives information about the heights of giraffes 1 year after they were born, as tracked over a 10-year period in a wild park in Kenya. We need a frequency density column, so make sure you add that in. Frequency density for your histogram, that's what goes on the vertical axis, and I need the width. So what I suggest is you pause the video and you go and complete those tables and then compare it to my answers once you finish to see if you've got the hang of it. Right, so I'm going to fill this in. The width here is 5, the width there is 10, 5, 10, 10, 10. Then to work out the frequency density, I say 10 divided by 5, which is 2, 25 divided by 10, which is 2.5, 12 divided by 5, which will give you 2.4, 33 divided by 10, which gives you 3.3, 22 divided by 10, 2.2, and 5 divided by 10, which is 0.5. Right, now we need to decide on the scale, and I notice that the highest frequency density is 3.3, so I'm going to draw my scale up to 3.5. I'm going to call this 0.5, 1.0, 1.5, 2.0, 2.5, 3.0, 3.5. Okay, right, let's go and plot this for 150 to 155. I'm going to make my marks there. 150 to 155. I'm going up all the way to 2. And again, it's good practice to use a ruler. Right, next section, 155 to 165. I put in my markers and I'm going up to 2.5, which is there. So draw that in. I'll do my shading this time at the end. Next section, 165 to 70, which is that section, is going up to 2.4. Just one row of squares below 2.5. There we go. 170 to 180 is going up to 3.3 there. Draw this in. There we go. 180 to 190 is going up to 2.2. That's 2, so 1, 2 is there. Draw that in. The final section, 190 to 200, is going up to 0.5. There we go. And then I just do some shading. Okay, so I hope when you did yours that it ended up looking the same. And I hope all of that makes sense. As always, if you have any questions, give a shout or drop a comment in the comments box. Hope this was useful.